Okay, good morning everybody. So this is cloud computing. I'm mostly telling myself rather than you because I have lots of this today. So today we're going to talk about VMware. Okay, so the first 2 weeks, so this week and next week, we will play around with VMware and we'll try to explore it as a software as much as possible so that we can learn as much as possible about it. The way to do this will be to actually create a deployment in your computers in the lab that is safe enough for you to be able to play around as much as you like with the software without having the fear of actually breaking anything. In order to do that, we will use a virtual machine that is called Prometheus. This is already built. Okay, it exists in all of the computers in the lab in A2.NET. It's in the global directory and it's in the format of a tar.gz file. So if you go onto your computers, you'll find in your global folder that there is a tb2 prometheus.tar. So what you will need to do is you'll need to copy it in your home directory, extract it from the tar archive file, and then that will create a folder called tb2 prometheus that contains all of the files that actually physically, sort of, contain the virtual machine. So virtual machines in VMware and in most other hypervisors as well, essentially are a bunch of files that are run in a piece of software and behave like a computer would. So this being a pre-built machine, it means that the operating system and everything inside it is already configured. So it's already there. All you will need to do is start it up. So for your computers, you will need to run VMware Player. VMware Player should already be installed on your host. And once you run VMware Player, you do File, Open, you find the extracted folder of the Prometheus virtual machine, and you open it up. When you start it, I think it will ask you if you've moved or copied this virtual machine, because each virtual machine has a unique ID. So it has there's another way to say this, isn't it? It has a unique ID. So each virtual machine has its own identity in the system. And so if you select I copied it, it will create a new virtual machine ID for that VM. The reason to do this would be, for example, the MAC address of the network cards will change. If you don't, then the MAC address of the network cards will always be the same, and if you put all these guys on a network together, which you probably will later on, then we might get into some trouble because of this. So make sure that you select I copied it, power it up, start it up, and what I would like to ask is that you always log in as root. So this is a virtual machine inside the lab. Alright, and everything you do in there will require administrator privileges. So you can just make your life easier instead of having to just SU for pretty much every single command that you type. You can just straight up log in as root into it and work at your convenience. Of course, in real life, this is very bad practice. Okay, you should always log in as a normal user and only elevate your privileges if you actually need to do something that requires that. All right, but because we are essentially in a test environment, we're in the lab, and there are no security considerations as such, unless you decide to hack each other, which is punishable. You know, we don't need to worry about it. So, log in as root, start the VM, and for the purposes of the module, what I would like you to do is I would like you to set this virtual machine to full screen. So from this point onwards, every time you come into the lab, what I want you to do is go on your VMware player, start up Prometheus, log into it, set it to full screen, and then you will only need to work inside the Prometheus VM. So absolutely everything that we do for this module will happen inside that virtual machine. Even installing VMware Player, which I will show you in the next steps, or installing VirtualBox later on, or installing and configuring OpenNebula, everything inside the Prometheus VM. Okay. This VM, by default, if I remember correctly, has an IP address of 28.253, so you will need to change this. You need to go into the network settings And the way that we change the IP addresses for our virtual machines here are, everything is on network 28, on subnet 28, so the NetLab itself, the computer's physical IP addresses start from 148.168.1 and they end at 148.168.48. So for the 48 PCs that we have in there, you will need to see what your IP address actually is. There is a little blue sticker on the bottom left corner of your monitor, and that number is the last part of your IP address. Be careful, that's the IP address of the physical host. Okay, you must not ever use this. What we do use is your IP address on the host plus 50. So if you're sitting on a computer with an address of 28.10, then your Prometheus must be 28.60. Okay, please be careful with this. What will happen is if you set the same IP address for both Prometheus and the host, your networking will sometimes work, sometimes won't. So the information will be either routed to the correct host that's asking for it or not. Okay, so it's a bit weird. What will definitely happen is that your Prometheus and your host will definitely slow down because they can get confused if they both have the same IP address and they send some information over to the internet, get it back, and then try to figure out exactly which network card this information is supposed to be going to. All right, so make sure you use your host plus 50 for the Prometheus IP address. Try to ping Google as a test to this in the end. And finally, so this is now general instructions about how you use the Prometheus for the entire module. Yeah, I would like you to make sure that Google Chrome is installed. I'm pretty sure it is installed in there. Okay, you can log in and you can save your information as well because you will have your own student account in the lab. So you are VM3, if I remember correctly, in this class, or VM4? VM4 in this class. Nobody else is going to log in as VM4 on that particular computer. And to that point, make sure you've changed your password as soon as you log into the computer as well. Yeah. So you can save all your information, you can use Google Chrome, and you can go to Moodle, get the lab seats, and work. Yes, we're not paid by Google or anything. You can use Firefox if you like, or Opera or whatever else. It's just a matter of compatibility, because I want your logbook to be a Google Doc, and it's the easiest way for you to get screenshots and paste them onto your logbook. That can happen inside, that should happen inside the Prometheus virtual machine to begin with. All right. So now that we have our host and we have the virtual machine that we can play around with, one of the reasons that we're doing all of this is because if you do somehow break your Prometheus VM, all you need to do is extract another one from the tar file and start all over. And this will happen more often than not. Yes? So for example, if you're finished with the VMware series of lab seats and you move on to the VirtualBox lab seats and your virtual machine dies, then you can extract a new Prometheus and you don't need to worry about the VMware lab seats as long as you have your screenshots and everything else. Okay, so as long as your information in your logbook is there and you have your screenshots and you tell me that your virtual machine died, then we should be okay. This tends to happen more later on during the Open Nebula installation. Okay, so we have the virtual machine that we're working on. So now that's our host. We will go and install VMware Player from scratch inside the VMware Player Run virtual machine that is called Prometheus that's running on your host. Okay, so this is called nested virtualization. So you're building virtual machines inside virtual machines. It's fine, or our computers can take it, so it's okay. So to install VMware Player, all you need to do is you need to find the bundle version of it. So make sure that when you download it from the website, you download the version for Red Hat Linux or Fedora Linux, as they call it there. Okay, so Red Hat, Fedora, CentOS, it's all the same. Download it, and the way to install it is you simply run // and then the name of the file. The file should have a bundle extension. If it doesn't have a bundle extension, then you've downloaded the wrong thing. All right. So with VMware Player installed, it's time to see how we actually build a virtual machine. This should be common knowledge to you because most of you, I think if not all of you, have done system administration and internet working with me last year. So give me a hands up if you haven't been with me the first year. Okay, yes. So we will need to build the virtual machine inside VMware itself. So first of all, we need to create the virtual machine. So we'll go into the menu and we say create a new virtual machine. Essentially, we're putting the hardware together that will support the computer that will be the virtual machine that will run inside our Prometheus. All right, so putting the hardware together means that we need an ISO image that we need to use in order to install the operating system from it. And inside Prometheus, you will see that there is a CentOS 7 64-bit ISO image. So that ISO image, you will use it as the DVD drive, essentially, for your virtual machine. Once you set that, then VMware itself will automatically detect what sort of operating system is inside that image itself. And it will say, great, this is CentOS 7, so we'll do a CentOS 7 installation. It will ask you for a root, for a username and password, and that password will be the same for the root user as well. And once you do that, it will take some liberties and move on with the rest of the creation of the virtual machine. What you need to be careful about is, first of all, and hence the red letters, the name of the virtual machine. At this early stage, you need to set it to be vPrometheus 0. The reason for this is that when you rename a virtual machine while you're building it, then all of the files that get created inside the folder physically on the virtual machine have the name of the virtual machine as well. Otherwise, the file names will start with CentOS space 7 space 64 whatever, and that will cause a problem later on for a script that we have that we need to modify the networking for our virtual machines, because that script doesn't recognize spaces. Okay. Yes, we could modify our script to recognize spaces, but we like to see this as a teaching moment for you all to be able to follow instructions to the letter when you're building something. Okay, because when you do go out to work somewhere and somebody tells you, I want you to build me this in that way, you need to build it in exactly that way. All right. So, give it some hard drive space of 20 gigabytes, and give it 4 gigabytes of RAM, whatever CPU it has, 1 core and so on, and move on with the rest of the installation. The installation will be an unattended one. VMware calls it easy install. So this means that it will not ask you for hard drive partitioning, type of software installed, networking information, and so on and so forth. So it is an unattended installation. It will do it, and it's less hassle for you, essentially. Let it run its course. Once it's finished, you will need to log in onto your vPrometheus 0 virtual machine. Again, I would like you to log in as root into this. Password should be localhost 1 for all of the accounts inside the virtual machines that you have, so that later on, if I do come and work on your computer, I need to be able to fix everything and know what the password is localhost 1. Once the virtual machine is built and you are logged in, you need to tidy up a little bit. So you will need to set the host name for this virtual machine. You did set it up as vPrometheus 0 when the virtual machine was building in VMware, but that is outside the operating system. That's the hardware side of it. Okay. The operating system itself, when you open a terminal and it gives you a prompt, it shouldn't say localhost or root at localhost. It should say root at vPrometheus 0. All right. In order to do this, you need to change your hostname file. So you need to go in there, change the name, reboot, and make sure that it all looks correct. Now, once we have a virtual machine that we can play around with, I want you to go and explore some of these settings of this virtual machine. So I want you to see what different running states the virtual machine can have, running, suspended, powered off, and so on. So this is basically you messing around with the virtual machine and trying to figure out how everything works. So theoretically, you can change the amount of hard drive space in it, you can change the amount of RAM, the number of CPUs. So settings of the virtual machine that can be done via software with a few clicks rather than you opening a physical box and taking hardware in and out of the computer. I also need you to go into your Prometheus VM and go into root VMware vPrometheus 0, and I want you to see the files that physically make up the vPrometheus 0 virtual machine. Alright, so I want you to know where they are located and what they look like. So you have the VMDK files, for example, that create the hard drive space, and their size will change according to the usage of the virtual machine. You have the VMX file, which has the configuration settings for the virtual machine that you're using. So for example, how much RAM, how many CPU cores, how many network cards and what type and so on. So I want you to go in here and explore. There are questions in here, so change the memory from 4 GB to 1 GB, what happens? In your logbooks, I want you to answer all of these questions. Okay. Next step, now that we build our test virtual machine, our vPrometheus 0, we need to explore the different modes of networking that we can have inside those virtual machines, or rather, what different modes of networking VMware actually provides us. So by default, when you're building a virtual machine, it sets it up as NAT, Network Address Translation. This is the easiest and most hassle-free way to give networking access to a virtual machine, because essentially it sets up NATing between the host and the virtual machine, gives an IP address automatically with a DHCP server that is owned by the VMware process itself, and has an IP address, has a point on the host itself that uses as a gateway, and gives internet access to the machine itself. The different modes of networking that VMware supports are NATing, bridge, and host only by default. So NATing is network address translation. So basically it does everything automatically and it NATs behind a private network. The second option that you have is bridge. So just like Prometheus is bridged onto the host and is running on subnet 28 with an address of +50, then you can also have another bridge inside it that bridges the virtual machine inside Prometheus again onto the same network. So if you're using IP addresses that are connected onto the same subnet on the same network, then this is a bridged connection. This is also a very straightforward connection because you don't need to set up any routing or anything like that to have internet access for the virtual machine that you're building. The third and last option that VMware theoretically provides is the host-only access. So this sets up a different network than the one on the host. So it sets up a different subnet, and theoretically communication in there is only possible between virtual machines that belong onto the same subnet. You can overcome this by creating what we have here. So we have a custom network configuration. So because VMware is very old, it depends on a bunch of scripts that are the configuration files for everything. So the script that this depends on is the VMX file, that is the script that starts up the virtual machine that you're running. So you can actually hack this VMX file. So you can use a script and you can go and change the network card settings on it, make it show up as custom, create something that is essentially host only, but is not managed by VMware itself. And this is exactly what our script, VM subnet 2, actually does. So you can read all the comments and everything if you want up here. So what it does is it goes into the VMX file and it changes the networking information for that VM. So more specifically, if we use this, so there's the fixed vmnet dev. Once you run this, your virtual machine will have 3 custom network cards instead of 1 native network card, or in fact, instead of any other networking configuration that you had there before. So, yes?
Will we need to rerun any of these scripts every time we open up the Prometheus VM?
No. So these scripts will be run inside the Prometheus VM, so that's a good point, and they will affect the vPrometheus 0 VM. Okay, so they will affect the settings of the virtual machines inside your Prometheus VM. So at the moment, generally your Prometheus VM's networking settings should never change. Okay, your Prometheus as a host should always be bridged, and the files that actually control the Prometheus VM are physically located on the host itself. So you should never change those. You need to be working one level deeper inside the virtual machines. So these scripts need to be run inside Prometheus so that they will affect the vPrometheus 0 new virtual machine that you built. Okay, so we are working in one level deeper than the standard host itself. So once you run these scripts, they will change the network cards of the vPrometheus 0 VM, and it will give them 3 custom network cards. So all it does is it looks for the Ethernet configuration settings and it changes them to what we have here. So it will create 3 custom network cards that you can essentially give host-only type IP addresses, so you can give them whatever IP address you like. Okay, and the VMware will just run with it. To configure those addresses, there is this other script, which is called vmsubnet2, and you run it on the host, and that will create a vmnet2 network card. So all of the network cards for VMware are called vmnet on the virtualization host itself. And I will show you this in the lab as well, just to make absolutely clear of what we're talking about. Yes?
Presumably we're also changing the VMnet IPs and other sort of network masks to our own VLAN ID.
Essentially, yes. So you will need to edit these IP addresses, this networking information here. All right. So you need to edit this networking information to reflect whatever networking configuration corresponds to your own computer. And that will depend on this file. Okay, so you need to see which computer you're working on by name. The IP address of the host of that computer is on the first column, so you'll be 148.168. something. So let's say, for example, that you're working on bottom. Your host is 28.8, your Prometheus is 28.58. Your bridged vPrometheus 1 will be 28.108. Okay. Your custom network will work on subnet 30 and will have an IP address of 30.29. So this will be the IP address that you will need to give into your VMnet2 network card when you're running this script. So you need to look at the information on that paper, on that file, subnet file, and decide what actually goes where. So the information that you will need to change is the IP address. So it will be on subnet 30 and it will depend on whatever is on your subnet file. The subnet mask will need to change. So it's not going to be a 255.255.250 default subnet mask anymore. It's going to change to 252 because of what we've actually done in order to be able to have this. Okay, so if we look at the second page of this, so the subnet mask for this is 252. The reason why this happens has been explained to you in the first year, so I'm hoping you sort of remember it, so when I explain it now, you'll understand even more. So, we have taken the network 30.0, which is a default class C subnet, that goes all the way from 30.0 to 30.255. So this is the size of a class C network. This has a default subnet mask of 255.255.255.0. Because we have 48 computers in the lab, we need to split this network into at least 48 slices. The way to do this is we need to split it to slices that are factors of 2. Okay, so we can either have 2 slices, 4 slices, 8 slices, 16, 32, 64. So 64 slices of this network are enough to accommodate our 48 computers. So we can have 48 networks, one for each of those computers. And it leaves us with a few spare ones as well, which I can play around with and you don't need to worry about. Okay, so because we split it into 64 slices, which power of 2 gives us 64? 2, 4, 8, 16, 32, 64. Yeah, 2 to the 6. So what we're doing essentially here is looking at the subnet mask, the 255, 255, 2550 in decimal for us humans to understand, translates into binary, into ones and zeros, yes? So we have 8 bits that this works on. So all of these together, if you add them all up as 1 plus 2 plus 4 plus 8 plus 16 plus 32 and so on, that gives us 255. So this means that all of the digits that are enabled here add up to whatever is up here in decimal. So if all of the digits are enabled, we get 255. If only 1, 2, 3, 4, 5, 6 of the digits are enabled, remember 2 to the 6th, yeah? Then if you add these guys up, 128 plus 64 plus 32 and so on, gives us 252. This has happened because we've split the network and we need 6 more digits in order to have the number of networks that we need for our number of computers. Alright, so in order to have 64 slices. So this will give us those 64 combinations. In the same way, the 2 digits here will give us what? 00, 01, 10, 11. 4 different combinations. So this part with the ones is now our subnet part of the network, and this part with the zeros is now our host part. So host gives us 4 combinations. 4 combinations for our network means 1, 2, 3, 4 combinations. So each computer has only 2 digits to play with for the addresses that are available to them. And because the first address has always need to be the network address and the last address always needs to be the broadcast address, we end up with 2 possible IP addresses per computer on subnet 30. So because we have 64 networks, the number of hosts available to use per network in there has now been reduced all the way from 254 to down to just 2. Okay, so this is how this matrix comes about. So if you are sitting on Farina, you have your network address of 0, you have your broadcast address of 3, and you have usable IP addresses of 1 and 2. If we go back into our subnet script, we have our network, which for Farina will be 30.0. We have our broadcast, which for Farina will be 30.3. And then we have the first usable IP address that we can use, which will be 30.1 for that particular computer. And of course, the subnet mask becomes 252 for the reasons explained above. All right, so this is what goes into this file. Even if you don't completely understand it, ask me if you don't, and I'll sit down and explain to you in person, yeah? Just looking at the subnets file, you can still figure out what addresses are supposed to go where. It's asking for a network address, you put a network address, broadcast, and then usable IP address, the VMnet IP, will be the first of the 2 usable IP addresses that you have. Why? Because the second of the 2 usable IP addresses will need to be allocated to the network card inside your vPrometheus 3 virtual machine. Okay, so the custom networking virtual machine that you will create will need to have the second usable IP address from this list, because the first usable IP address from this list will go on to the VMnet 2 network card that you will create, and that network card will be located on Prometheus. So these scripts will need to be run on Prometheus so that they affect the vPrometheus 0, 1 to 3 or whatever that is inside of them. So VMnet 2 will run on Prometheus, and it will be the contact point. It will be where the virtual machine 3, your custom virtual machine, will actually connect to in order to get to the outside world. So if you're sitting on vPrometheus 3, you're connecting to VMnet 2, which connects through Prometheus and goes out to the outside world. Okay. So once you have that in place, then you have the custom networking in place as well. So for this lab sheet, you will need to create 4 virtual machines inside your Prometheus. The first VM will be the VM that you had to begin with, the one that you built, which will be the VP0 and it's NATed. The second VM will be the bridged one. The third VM will be host only, and the fourth VM will be your VP3 custom with a custom networking. How do we create these 4 virtual machines? You don't have to build them again. All you need to do is you need to go into the root folder, into the VMware folder, find the folder of vPrometheus 0, and this is happening on your Prometheus host, and simply copy that folder and paste it next to it. That will create a folder called vPrometheus 0 copy, which you rename to vPrometheus 1, and then you can copy it again and make vPrometheus 2 and vPrometheus 3. Essentially, you're cloning the virtual machine that you built, so you don't have to build the same thing again and again and again. All right. The only thing that you need to be careful about is when you start these virtual machines up, they will ask you if they've been moved or copied, just like Prometheus did when you first extracted it and ran it on the host. And you need to say I copied it so that it creates a new, unique virtual machine address for the new virtual machine that you created. So that way you'll have the 4 virtual machines, you can play around with the networking modes and see what happens. Custom networking is essentially what I explained, so all of the instructions are here in detail. Of course, if you get stuck in the lab, please ask either me or one of the assistants and we'll help you around with it. And then finally, once you have all of the 4 networking modes working, and you can ping the internet or not, depending on what the modes support, you can, if you have plenty of time, within the 2 weeks, go on to the final unassisted task, which is to set up a routing so that you give access to your custom vPrometheus 3 to the outside world. Because remember, we said that the custom settings are sort of an informal host-only configuration, but it's on a different network. It's going to be on subnet 30, and you cannot have internet access on subnet 30 unless you're doing some routing between subnet 30 and subnet 28 or the rest of the world that we have here. Okay. In order to do this, I won't explain it in detail, but if you do go on Moodle, there's a folder called routing utils, and in there, there's the 2 configuration files that you need, and there is actually the routing lab sheet for reference so that you can follow this process and try to get it to work. Of course, it will require some research on yourself as well, and we will not really help you so much with this, because this is something that we want you to figure out how to do almost by yourself. Okay. So the VMware lab sheet work, or the work in the lab should start this week. So you're in the lab tomorrow morning, if I remember correctly? Yeah. So this week and next week, you should be dealing with VMware. Ideally, by the end of next week, you should be finished. You should have built all of your virtual machines. You should have all of the networking modes and them configured. And if you can, you should have done routing as well. After that, you'll have 2 weeks to work on VirtualBox. You can choose to either leave VMware as it is, come and pick it up and work on it on your own time, or leave it for the end of the teaching block, all right, and move on to VirtualBox and so on. Or if you think that it's going relatively well and you can get all your screenshots and everything, get all your screenshots and work on it. Another thing that you can actually do as well is if you're finished with the VMware lab sheet and you have all of your screenshots and everything for your logbook, then you don't worry about it and you move on to VirtualBox, get all of your screenshots, move on to OpenNebula, and then you can make a backup of the virtual machine. So essentially you can go onto your host and you can take your Prometheus VM and copy it and name it backup Prometheus backup and give it a date. So that will include your VMware and VirtualBox lab sheets that are done inside it. And then later on, if in OpenNebula you do actually kill your virtual machine, you don't need to worry about it too much. You have a starting point, you can retrieve your backup and continue working on that as well. Okay, so that's a good idea, it's a good practice. We have plenty of space on the computers, and this year we have fewer number of students, smaller number of students as well, so we really don't have a problem with space. So if you do need to make a backup, make a backup. Please don't keep more than one backup. Okay, because the VMs eventually will become almost 100 gigabytes, so it is quite a burden. Okay. And that should be it for the VMware lab sheet. Do you have any questions about it all? Remember, ask in the lab. Okay, so it will be myself and probably 2 or maybe even 3 more people helping there as well. So ask. All right, thank you very much.